Welcome back, geometry students. We are on page 217 of your student journal. We are actually on lesson 7.5. So this is the last lesson in this chapter, and so we're kind of finishing up. We're going to talk about two different kinds of quadrilaterals and talk a little bit about their properties and show you some different relationships. So the first one we're going to talk about is a trapezoid. And so you probably are familiar a little bit, at least, with a trapezoid. So first and foremost, it's a quadrilateral, which just basically means it has four sides. And so what's special about this one is it has exactly one set of parallel sides. Oops. So it makes it different than a parallelogram. Okay, so this is not a parallelogram. And the reason why is because it doesn't meet the definition of a parallelogram. And so in a parallelogram, what you would notice is that it would have two sets of parallel sides. And so in a trapezoid, kind of looks like that, in a common one at least. In a trapezoid, what you will have is one set of parallel sides. So you would be you would know that like this side and this side are parallel. So again, we mark them like that. There are some different things about the trapezoid that you should probably be aware of. And so bases, there are two bases for a trapezoid. There's one on top and one on bottom. And so if you ever did the formula for the area of a trapezoid, it was like 1/2 the height times base 1 plus base 2. Well, that's because it has two bases. Your base angles. So basically there are four base angles, and well, these four are what the four angles of your trapezoid are going to be your base angles. And so what we're getting at here is there's going to be some relationships between what we know about the base angles, given if we know like the side is congruent to this side and so forth. The last thing is the legs, I should say, of our trapezoid. And so in this case, we have two legs, one on both sides. In certain cases, we will have those legs being congruent. And when that happens, then we have what we call an isosceles trapezoid. So when the legs are congruent to each other. So when these two sides are congruent, then what that tells me is that this is what we call an isosceles trapezoid. And so it doesn't always have to be that those two legs are congruent, but in special cases, and a lot of times the more common looking trapezoids you'll see are the ones that are isosceles. All right, so then the next thing I want to talk about is something that we're going to talk about today is called a mid-segment of a trapezoid. So let's draw a trapezoid. A mid-segment of a trapezoid is kind of like the mid-segment of a triangle. Basically, you find the midpoints of your two legs. So again, this side is equal to this side is equal to this side. So the midpoints of your legs. And then this mid-segment, excuse me, that is what you call your mid-segment. So that length right there is called a mid-segment. So we're going to talk about some relationships about what we know about a mid-segment. And that's going to be some of the theorems that we're going to discuss here in a minute. But that's what a mid-segment is. It's a segment that connects the midpoints. It's parallel. It's going to be parallel to your bases. And so that's kind of how you know which direction to draw it. It has to be parallel. So eventually what we're going to talk about here is that all of those lines have to be parallel. All right. So the last thing is something called a kite. So a lot of times people refer to this as a diamond, but the mathematical terminology is a kite. So it's a quadrilateral, so we'll start there. But this one is unique. It has two pairs of consecutive congruent sides. Okay, I'm going to write that down, and then we'll talk about it. So two pairs of consecutive congruent sides. What makes this one unique is that, but opposite sides are not congruent. So what makes this one different than some of the other shapes? And so a lot of times it'll look like this. So that might be how the kite is drawn. And so, for example, two sets of consecutive sides that are congruent. So like consecutive means so like this side is congruent to this side, and this side is congruent to this side. But what makes a kite different than, say, a rectangle or a square or something like that is that this side and this side, opposite sides, are not congruent. So remember with a parallelogram, we talked about the fact that in order for something to be a parallelogram, opposite sides have to be congruent. Well, so then this quadrilateral is not a parallelogram because opposite sides aren't congruent. If a trapezoid, so now we're going to talk about several different theorems that probably are going to be important to you as we kind of go through. So this one is the isosceles trapezoid base angles theorem, which is kind of a lot to say. But basically we're kind of going back up to that isosceles trapezoid thing, which tells me that my legs of my trapezoid are congruent. So it states, if a trapezoid is isosceles, then each pair of base angles is congruent. So what that means, if we kind of go up to this one, let's say we knew that this leg is congruent to this leg. That means these two angles have to be equal to each other, and then these two angles have to be equal to each other. So there are going to be some times when that's going to be extremely relevant. So like here, they just wrote A and D are congruent, and B and C are congruent. Theorem 7.15, which isn't really important that you memorize that, but what we need to know about this theorem is the isosceles trapezoid base angles converse, which is pretty much the exact opposite we just set up here. So if we can show that A is congruent to D or B is congruent to C, so any set of base angles, if we can show that they're congruent, then this trapezoid has to be an isosceles trapezoid. So again, if we can show that either set of base angles is congruent, then we know that that trapezoid is an isosceles trapezoid. All right, there's some more theorems on the next page, so let's take a look. All right, so theorem 7.16, isosceles trapezoid diagonal theorem. So this one states, a trapezoid is isosceles if and only if its diagonals are congruent. So we know that another way to kind of prove that this trapezoid is an isosceles trapezoid is if we can show that this diagonal is congruent to that diagonal. So again, you would use this if you're trying to prove this trapezoid is isosceles. So here's that mid-segment theorem that I was kind of alluding to when we talked about what a mid-segment was. So again, in this diagram, MN is your mid-segment. So this is what we call a mid-segment. And there's some information that you need to know about a mid-segment. So first and foremost, they're all parallel. So the mid-segment, which is MN, is parallel to AB, is parallel to DC. Notice how then this obviously has to be a midpoint and has to be a midpoint of BC. So all those pieces have to be congruent. The important thing here is also there's a relationship between the length. If you remember when we talked about like the mid-segment of a triangle, there was a relationship between like the length. So same, kind of similar idea, a little bit different formula. So what we're saying here is this mid-segment is equal to half the sum of the bases. For example, if I know this base is 8 and this base is 12, then the length MN is equal to half of the sum of the two bases added together. So I would add 8 and 12 together and then take half of it. So that would be half of 20, which would be 10. So I would know that that length is 10 because it's half of this base plus this base. And that's what a relationship with that mid-segment is. So you're gonna wanna know that. We're gonna do some more problems with that. All right, the last two theorems that we're going to chat about are going to be about the kite. So this one is the kite diagonal theorem. And so it states, if a quadrilateral is a kite, then the diagonals are perpendicular. So this is one that we're going to fill out on the sheets. We know that if this is defined as a kite. So in other words, the kite means that it has to have two sets of consecutive sides that are congruent. So this side, and then this side and this side. What we know, if it's classified as a kite, then those angles have to form right angles. So all of those two, so CA or AC is perpendicular to BD. And so that's one of the pieces of information we would know if we are given that that is a kite. The other thing is the opposite angles theorem. And so if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So again, if we know that this is a kite, so if we know that this side is congruent to this side, so consecutive sides are congruent. Not only do we know the diagonals are congruent, but what we also know is one set of opposite angles have to be congruent. So like, for example, C has to be congruent to A, only if B and D are not congruent. Because if B and D are congruent and C and A are congruent, then that is not a kite. Okay, so that's what makes this important. One set of opposite angles have to be congruent. All right, so that's a lot of theorems. A lot of times this works better is if we kind of work through some problems. And so that's what I'm going to have you guys do right now. So we're going to go through some problems together, and then when you're in class, you guys can work on some of the practice and so forth. So we're on page 219 of your student journals. I'm going to suggest, so for number 1, it says, show that the quadrilateral with vertices at, and it gives you 4 points, is a trapezoid. Decide whether the trapezoid is isosceles. Then find the length of the midsegment of the trapezoid. So there's a lot going on here. So I am going to jump over to this paper here. So I am going to go ahead and graph this on a regular, normal size grid paper, because this gets a little cramped on that piece of paper there. Okay, so if you want to go grab a piece of graph paper, I would encourage you to do so. All right, so the first thing I'm going to do is I'm going to go ahead and just plot all 4 of those points. So Q is at the point 0, 3. R is at the point 0, 6. S is at the point -6, 0. And T is at the point -3, 0. All right, so this is a quadrilateral. So you can grab a straight edge, or if you can draw it as straight as possible. So basically, this is our quadrilateral. Okay, so everyone sees that. All right, so the first thing says, decide whether the trapezoid, decide whether the trapezoid is isosceles. So they're telling us it's a trapezoid. We're trying to determine if it's isosceles. So the first thing you want to do is identify the legs, right? So the 2 parallel sides, so if this is a trapezoid, then this side is parallel to this side. And so obviously this side here is not parallel to this side here. So that's how I knew those were my parallel sides, which makes RQ and ST the legs. So in order to prove this, you want to figure out the distance from R to Q. And this is fairly easy since it's a vertical line, so we can just count. And then you want to show the distance from S to T. Again, same deal, it's a horizontal line this time, but the distance is 3. So because we know that these are both the same distance, then this proves that this side is congruent to this side, and therefore, because they're the same length, I'm just going to write same length equals isosceles trapezoid. Okay. So next part on our, if you read the directions, it says decide whether the trapezoid is isosceles. So we did that. Then find the length of the midsegment. Okay. Oh, I forgot to do the first part. So let me go back to this. It says show that the quadrilateral with vertices Q, R, S, T is a trapezoid. So I kind of assumed that it was. So let's go back and show that it is. So if you were asked to show that this is a trapezoid, you would have to show that it has one set of parallel sides. So what I'm going to do is I'm going to do the slope of SR. So that's here to here. And so you can do the formula, or you can do rise over run. For whatever reason, I like to use the formula. So I get 6 over 6. I get a slope of, for SR to be 1. I'm going to show that it's the same as the slope of TQ. So the slope for TQ is, and I'll use my formula, I got 3 over 3 equals 1. In order for me to show that this is a trapezoid, I can't just stop here. I can't just show that it has one set of parallel sides. I have to show that the other 2 sets are not parallel. So I'm going to go the slope of RQ. So the slope of RQ is a vertical line, which means the slope is undefined. And then the slope of ST is a horizontal line, which means the slope is 0. So by showing all of this, okay, this shows, or this proves, I should say, we have one set of parallel sides. And therefore this equals a trapezoid. So that's how I proved something was a trapezoid. Again, we didn't use a formal proof, but we used kind of like just a mathematical proof, showing our work and justifying with some words, like explaining what we did. So again, just showing the work isn't good enough. You have to explain what you're doing here. So I did the work and then I said, well, we have one set of parallel sides. You might even kind of notice that you would write, you know, same slope means lines are parallel. So again, you want to make sure that you're clear when you're explaining your work so that you're not missing anything. All right, so this is kind of our proof, if you will, for showing that it's a trapezoid. We showed that it's an isosceles trapezoid, and the last thing we have to do is find the length of the midsegment. So what I'm going to do to find the length of the midsegment is I need to find midpoint of RQ. And so the midpoint of RQ, since it's a a vertical line, you could just use the formula, add up your x's, divide by 2, add up your y's, divide by 2, or you could probably just do it graphically. So I got 0 and 4.5. Now I'm going to find the midpoint of ST. Same deal, you could find it graphically or you can use your formula. So -6 plus -3 over 2. And 0 plus 0 over 2, so I get -4.5, comma 0. So what I did here is 1, 2, 3, 4.5, so that's about, so those are about my midpoints. All right, so to find the length of the midsegment, what I would need to do is, there's a couple ways to do this. So I'm going to show you 2 ways to do this. So to find this length right here, since I know the 2 midpoints, I can just find the distance between those 2 points. So that's going to be my first strategy. And so I'm just going to find the distance between those 2 points. So I'm going to use this point and this point. So I'm going to go -4.5 minus 0 squared plus 0 minus 4.5 squared. And so I get, if I square, I get 20.25 plus 20.25, which equals, this one is not going to be a one we can reduce the radical, so it's about, we'll use the wavy lines, about 6.36. So this is one way of finding the length of the midsegment. So this is length of the midsegment. Okay, another way of doing this is to go ahead and use our formula. So this is an OR, okay? So this is not, sometimes it would be better to use one way versus another. I'm just showing you both methods. So another way is to find the length of our bases. So if I did this base and this base, find those lengths, add them up, and divide by 2. So remember, our formula would be 1/2 of QT, which is the one base, plus the length of SR. So in order for us to figure that out, we would have to figure out the distance of Q to T. So you can use Pythagorean theorem here if you wanted, or you could use the distance formula if you wanted. But I'm just going to use Pythagorean theorem since I used the distance formula for the other one. All right, so the distance of QT, I'm just going to go a squared plus b squared equals c squared. So 3 squared plus 3 squared equals c squared. So I get 18 equals c squared, or I get root 18 equals c. Okay, so I'm going to plug that in here. So root 18 is my one length. Now I'm going to find the length of SR. I'm going to do it the same way as I just did the last one. I'm just going to use Pythagorean theorem because this is 6 and this is 6. So a squared plus b squared equals c squared. So 36 plus 36 equals c squared. That's 72, which makes the square root of 72 as our c value, or in other words, this SR. okay? All right, then you'd grab your calculator, do the square root of 18 plus the square root of 72, add them up, divide by 2, and you get approximately 6.36. Now, I'm not sure which way is like faster or easier or whatever, but either way, it kind of, one way is using that mid-segment formula, which is kind of using what the definition of a mid-segment is, finding the midpoints and then finding the distance between them. I mean, either way, you're doing some work, and I do need to see your justification for that, so just make sure you're showing all work on this. All right, that was number 1. That was a lovely one, right? Let's go back to this. The other ones are a little bit easier to do, doesn't take up as much room, so let's go ahead and take a look at number 2. So number 2 says, find the measure of angle K, find the measure of angle L. All right, so what we know is that, all right, so I'm going to do measure of angle K, measure of angle L. All right, so if these sides are congruent, then what we know is that our base angles have to be congruent. So remember what we talked about with knowing that an isosceles triangle has congruent base angles. So we know L has to be 23 degrees. So knowing that, right? So knowing that, what we're going to, so we know this is 23 degrees. The other thing what I did is I said, well, I also know that all the interior angles of a quadrilateral have to add up to 360. So I'm going to take 360 and I'm going to subtract 23 and I'm going to subtract 23. Or in other words, I'm going to subtract 46. And I get 314. So I know that there are 314 degrees left for angle J and angle K. So again, knowing that this is isosceles, we know that those two lengths, J and K, have to be equal. So in other words, I'm going to divide that by 2 and figure out that each of those angles is 157 degrees. Let's try another one. So same deal here, we're finding the measure of angle K, find the measure of angle L. So this looks like a kite because it has consecutive angles that are congruent, right? So in a kite, we know that one set of opposite angles have to be congruent. Well, since this is 90 and this is 130, then we know obviously these two are not congruent. So that means L and K have to be the same measure because in a kite, opposite angles have to be congruent. So I'm going to do kind of the same deal. I'm going to take 360 because it is a quadrilateral and I know all 4 sides inside the quadrilateral, all 4 angles have to add up to 360. So I'm going to take 360 and I'm going to subtract the 2 angles I know, which are 90 and 130. And so I get 140 degrees, which means angle L and angle K have to add up together to be 140 degrees. And since they're the same measure, because they have to be congruent by definition, then we know that each of those angles has to be 70 degrees. All right, let's do some more. Number 4 says find the measure of CD. So CD, notice that they're showing you that it's a mid-segment. So they show that D is a midpoint of whatever this line segment is, and C is a midpoint of this line segment. So basically what I'm asking you to do is use your formula for mid-segment. So add up your 2 bases, which are 12 and 36, and then take half of it. So this would be half of 48, which would be 24. So C to D is equal to the distance of 24. Number 5 is very similar, except this time they gave you the mid-segment. So basically here, we know that that's kind of our formula, right? The mid-segment, MN, is going to be equal to 1/2 of the 2 bases added together. So if we know MN is 1.8, and we know one of the bases is 0.6, let's solve for the other base, is essentially what we're going to do. So I'm going to get rid of this 1/2 just from the beginning. I'm going to go ahead and multiply both sides by 2. So I get 3.6 equals 0.6 plus B2, and then I'm going to subtract 0.6. So I get this base to be 3, which means CD is equal to 3. All right, right, let's do a little bit harder ones. These ones involve, so this one is involving that mid-segment theorem. And so again, showing you this is a trapezoid with this line segment here in the middle being our mid-segment because it's parallel and also connecting the midpoints. So again, knowing the relationship. So what we know is that this line right here, so 3x minus 2, is equal to half of x plus 11 plus 3x plus 3. So again, I'm just setting up a big equation. This line segment here is equal to half of this plus this. So let's go ahead and combine some like terms, maybe start there. So I get 4x plus 14. And then you can distribute the 1/2 or you can multiply both sides by 2, doesn't really matter. And then let's solve for x. So I subtract and then I add 2, I get x to equal 9. All right, last but not least is this kite problem. And so again, what we have to remember is that in this, in the kite, we know that the diagonals are perpendicular. And in this case, this length here has to equal that length here. So 9 has to equal 1/10 x minus 1. So this diagonal right here is basically bisected. The other diagonal bisects it. So I'm going to add 1 to both sides, and then I'm going to multiply by 10. And then I know that x is equal to 100. All right, so hopefully that makes a little bit more sense. I would try some of this stuff on your own, and if you have any questions, bring them to class. All right, bye for now, everyone.